So in this session, I would like to do the right shifting. Okay, so left shifting we have done in detail. We understood like so many concepts we implemented. So maybe the same program I just altered, and I would like to show you how we will be doing the right shift. Okay, so here so far we discussed why I am just including std int.h. All right. So I would like to declare the variable in this format. Okay. I would like to make sure that the number is 32-bit. Okay, so the same program I'm using, enter the number. So users will be entering a number in the decimal format, let it be, and the corresponding hexadecimal representation of the number I'm printing. All right. So if I am doing the right shift, you can see this operator only changed. Okay, so this is actually right shifting. So whenever we are doing the right shift, I told that the decimal number will be divided by 2. The value is actually decreasing. Right shift means the value will be decreased. That's it. If I am having 1000 rupees, the one I shifted right side by 1. So what happened? It become 100 rupees. Then again, then it become 10 rupees like that. Then again, it become 1 rupee. So if I am doing the right shifting, the value is getting decremented. That's it. So just to implement that, I did already right shifting by 2, 3 and all. So here, actually the number is getting divided by 2. Okay, so the value will be, I don't want to write it. Okay, so by default, it is actually getting divided by 2. I would like to show you these values. We can cross check whether it is correct or not. So that's the reason inside the printf I written num1 by 2. Even if you are not writing, by looking at the decimal numbers, we'll be able to understand how it is happening. Okay, how it is getting shifted and all. I already built this program, so let's run it. Let me go to the properties and open the location. I haven't changed the file name, but it is actually doing right shift only. Okay, so maybe the same data I'm checking 47. So 47 is the original number, the hexadecimal representation we got something. And each and every time, okay, so this is actually right shift by 1. So the value got divided by 2. And again, then half we are getting. Okay, so the result we are getting, the remainder we are just excluding here. All right, so this is how we are getting. This is what the right shift and left shift. Okay, it's not just I don't want to show you, okay, the value is increasing by 2 or getting divided by 2. That is not the concern. The concern is that you should know where actually it's getting shifted. Okay, how it is getting shifted. If I am writing a variable shifted by 2 position or shifted by 3 position, like in the actual program, we won't be writing all the story, right? Shifted by 1, shifted by 2. So there we'll be writing, you can ask the user, you can write a program, just everybody make a program. Okay, so listen carefully. The question is that you should ask the user enter a like a decimal number. Let them enter any decimal number. If you want represent the corresponding hexadecimal, then you should ask the user, okay, what that means, how many position, how many bit position they would like to shift. Okay, suppose if you are having a binary number which is of 8-bit. Okay, 8-bit long binary. If you are having 8-bit means 1 byte, right? So 8-bit number, suppose you have, of course you can work with 32-bit number. You have to work with 32-bit number. But for the simplicity I am telling, suppose if you are having an 8-bit number, then you should ask the user, okay, how many bit position they would like to shift. So suppose the user is entering 3 position. Suppose the user is entering 5 position. So then the given number you have to shift that much position. Okay, then you have to print the output. So that's the question. I hope all clear about it. It's very straightforward. You will be asking two inputs from the user, and the output will be like that. The given number, if it is right shift or left shift. Suppose if it is left shift, okay. So the given number left shift by the bit position or the number of bits whatever the user entered. User entered 3. So it will be number, okay. So number then left shift by like the bit number or the number of bits. Okay, so the number left shift by 3 if they entered 3. So then that output you have to display. So the output you can store it in a separate variable, then that output you can display. All right. So whenever you are declaring the output variable, so that time also make sure that you are using this format. Okay. Maybe you can use this format. All right. So int 32 underscore t output. So then you can ask the user for how many bit position or how many bit they have to they have to shift. For that you can again, if you want, you can declare one more variable. So that variable will be bit number or something. Okay, I'll be using bit number. So num1 and bit number, these are the both inputs we are taking from the user. Then output will be a variable where you are doing the calculation. Output equal to, so like you have to write one more scanf. I'm not writing the entire thing here. So maybe you can do like that, output equal to, okay, it's better to use a space, better practice. So output equal to, so the num1 will users will be entering num1 whatever shift it is, num1 shift. Okay, so whatever bit number users like given. Okay, so this output, this data or this output, you can store it in the output variable. Then just print it. Output variable like decimal, okay, or the hexadecimal, whatever you like, you can print it. So that's the question. I hope it's clear. All please try to practice it. Okay. So maybe in the coming sessions we'll be discussing about the AND, okay, or XOR and all. So that will be like maybe little advanced concept compared to this, and there we will be using this shift operators also. Okay, we are not like about to use only the and or separately, like it's not only using separately. We will be using this and all with the shift operators. Then only we will be able to implement some better logic. So that's the reason initially I discussed about the left and right shift operator. Be very clear about it. Then you have to like go to the next sessions. From the coming session onwards, we are actually doing the embedded programming. Okay, so how you will control the LEDs, how you can make certain LEDs blink, okay, how you can use the mask value. So all this concept I am going to discuss in the coming session, right? Yeah, so this session was very simple. We have done already only the right shifting, that operator we used, that's it, nothing else changed here. And we already got a conclusion that the value is actually decreased whenever you are doing the right shift. That's it. So with this note, I'm ending the session. Let's meet in the next session for more bitwise operators. All right, then thank you all. Bye. Take care.